a test right now of the capacitive touching elements, and you have to pay attention here. There are small little pieces of metal like this. This is a jumper for two adjacent holes. This is it. This is the jumper, and that one, and that one, and that one. And this four, I arrange them conveniently like that to be able to do this. So check this out. Sometimes it is trailing or freezing, as you can probably see there, when I'm touching two at once, and sometimes is remaining. Or if I'm touching it a tiny little bit and I'm not completely sure when I'm getting two of them, or probably is not working. Yeah, now I'm having all of them lighting up. I must have a more decisive element or circuit, and from what I figured out, so it worked absolutely perfectly the last time, like this. This is perfect. If I'm letting enough time, my finger on the contact is doing the proper thing, you see. But if I'm hurrying it, if I'm moving it very fast, sometimes it happens this kind of error that two or three or all of them remains lit up. So that's it's because of the speed. So I have to be quite slow here and to touch all these four like that. I'm actually touching the bases of these transistors. So these transistors are exactly this BC548, and I have them here, these guys. And originally I was testing like this, pack, you see, like this, over here, you see, with my tweezer, with my metallic tweezer, and it is not stalling, it is not doing anything weird. Now, when I'm making these tests here, it is not remaining, you see. I don't have two of them, or multiple of them, but when I'm doing this, it's kind of grabbing, which is not good. I believe that the base of the transistor is not opening that much, and it's kind of retaining a tiny little bit of of capacitance, probably in this wire as well, and in this board too, and everything combined is making that base of the transistor most probably, this is my explanation, is making it not close back perfectly, is remaining a little bit open, and by remaining a little bit open, it means it's having a little bit of charge remained on the leg from something, from this wire, from this metallic element, from the breadboard itself, everything combined. I have no idea, but by remaining a little bit open is letting the current flow and is enabling multiple gates open. You see how it's flickering a little bit. Probably it's my 50 hertz that is passing through my body. Most probably that's why it's flickering a little bit. Probably the camera can see it, but with my naked eye I cannot see shit. But my camera kind of catching a little bit of flickering. Yeah, well, that's not the problem. The problem is that it's remaining activated, like multiple of them, and that's annoying. Well, I've seen probably a remedy. I've seen another version. Instead of simple transistor like I'm having here, using Darlington transistors. Either one package having two transistors in it, or two transistors, one and one. But it's way too expensive to have. I mean, it's getting too agglomerated, everything. So what I'm having here is quite compact with these transistors. I tried integrated circuit to use. It is giving me all sorts of errors. Sometimes it's lighting up, sometimes it's not. So it's not good with an integrated circuit. I tried two of them on ULM 2003. I have it here, and an AND. Let me show you my box of treasures here. An AND gate. I never used any of these AND gates. I have a ton of them, and I don't know what to do with them. So I tried to use one chip like that, and it didn't work either. So yeah, I'm a little bit disappointed. But I believe I will find a way. So this is a little bit of test for the touching element so far, and how sensitive it is, how responsive it is. It is very responsive, but it is lagging like this too, you see, it's lagging, and I don't like this lagging, and I will have to do something about it somehow. I'll have to find a solution. So I don't know the exact cause. I'm guessing it's those bases of the transistors, but I'm not really completely sure what is really happening here. So far, so good. So this is it until here. See you next time. All right, hello, and welcome to another new episode from the glorious Q12 here experiments. I managed to do this, so I extended with another chip there, but until this stage that I am right now here, that you are seeing it, and it's functioning quite okay. I'm quite happy with it. I did a lot of experiments, and I got into the woods, and for a few days, actually for 2-3 days like that, every day I experimented and I tested, and I was thinking, and I was desperate at some points because I was thinking it will not work as you are seeing it now. But right now is not still yet out of the woods. It still has some errors. Sometimes, most probably some components here are moving, especially these resistors that are, you see, they're very, very flimsy, and they sometimes they don't make contact for some reason, I don't know. And sometimes it's giving me some errors, very strange errors. Like this, like see, when they are staying both lit. This is the only error that I'm getting. Come on, yeah, like that. You see, and sometimes everything is getting lit. Most probably is because of this all this wiring, all this some flimsy components that I'm having here, even the transistors. The transistor they are having a great role. These are BC548 transistors, brand new, but I experimented with them in time. But theoretically they are brand new. Let me explain a little bit the circuit here. When I'm touching one of these metallic elements that I'm having here, and if I'm doing this, you see, this I put a 10 kilo, and then to the base of the transistor. Theoretically is working without this 10 kilo, but to be sure, who knows what high electrostatic voltage on your skin, it's probably better to use this 10 kilos here. But theoretically is working without them as well. But for the protection of the base of the transistor, is good to have this protector resistors here from your touching. You see, this is the error. You see how everything is getting leaked. I really hope it's only here on my setup that I'm having here on the breadboard. I'm putting my elbow here, you see, on this, and if I'm touching, I'm making some sort of connection to the ground, and now not all the time, but sometimes I get it through the, yeah, you see, now I'm getting a little bit of that effect. It must, yeah, you see, I have to press a little bit through the material is making the contact. It's making some sort of, yeah, that's most probably that must be it. I'm not completely sure, but sometimes I'm leaning with my hand on this thing which is grounded. It's directly to the ground, and through this material is making some sort of connection somewhere, is an effect. And I don't think, I'm just leaning my hand without thinking, and then experimenting here, and what the fuck, and I'm getting the what the fuck, yeah. But sometimes it's without that element here. So sometimes it's doing it by itself, and it's not good. Let me talk about all these other experiments that I did here. This is an inverter, is a Schmidt trigger inverter, 7414, and these are two op-amps. And probably I will show the circuit that I built. I tried to figure out a way around this error. When two of them are lit like this, when two of them are lit, I tried to deal it, to make it some sort of a logical. It did work in my simulator, but here in reality, it didn't work at all. The original circuit that I made, I included these transistors, and today I remake everything, and I included this third one as well. Why it didn't work with these guys here? It did work perfectly fine in the simulator, but here in reality didn't work. Why? Because I put my scope there on everywhere, on those op amps, on this inverter, and I was getting, when I was touching here, I was getting a consistent 50 hertz. So the 50 hertz from my hand was transmitted to the input of this op amps, one op amp, not two of them, only one, and then further to this NOT gate, and then further to the clock of these flip-flops. It didn't lit up anything, I believe. Yeah. It didn't lit up anything. I only had some LEDs here on the NOT gate to output LEDs to signal to me, to show me when is a signal on the output. So I knew for sure I was having a signal on this output of this NOT gate, but here on the flip-flop, I didn't get anything. I didn't get any output. Like they were saying off all the time. And then I most probably this must be it. This was the problem, because the op-amp is amplifying extremely well, is reading extremely well the signal, especially 50 hertz. It was transmitting this 50 hertz to this flip-flop. The clock pin was seeing 50 interruptions per second all the time. Theoretically, I should have seen the LED lit at 50 hertz, but I didn't. And I thought maybe it's this very small amplification of the signal of my 50 hertz from my skin, and it transformed it into a serious signal on the clock, and that was my explanation. And because I was getting after so it was like this: the signal was coming into the op amp, and from the op amp was getting into this NOT gate, and from the NOT gate to the flip flop. This was the order, and here was the buttons, and I was clearly seeing an output on these LEDs from the NOT gate, but not here at all, and nothing. In the simulation, this op amp, this combination, especially this op amp, because it was around him, he was doing the lifting job. Actually, I have here the circuit. I copy it. Here it is. These are the buttons are coming into the op amp, and here from the op amp NOT gate to transform it into the correct signal that I needed. And this arrangement that I'm having here was for this button until this diode. This signal from here was actually on this diode intersection with that clock wire. You see, it's directly going to the clock there, and it was here connected on all this mumbo jumbo. So pretty much I made a way of sorting between two lit up LEDs into one single LED. Pretty much this is kind of sorting it out, and it worked exceptionally fine in the simulator, but here in reality it gave me some fucked up errors, very fucked up. And then I reversed my original circuit that I made, it exactly this one that I'm having it here, and is what you are seeing here on my table. It should work absolutely fine, perfectly fine, like you're seeing right now. All right, I will explain very briefly what I did for this secondary circuit that I tried already on my breadboard. Here I will show you only how it's working here in the simulator. So the most important thing is read this line here: op amps output, which means this output here signal must transmit a low as enable. It's actually specified here to 7474 clock pin.
and so low as enable by default must stay high as disable. So when it's high, is disabled for this clock to to function properly. I did it normally like this without that without this inverter or here on the end, and it didn't work at all. It was throwing me all sorts of errors, and then I realized I need this inverter, and that's it for this part here. So this is the most important thing to understand first, and this is the flow. What I'm doing right now is this is the flow how my finger is going through these pads or links. So from here is creating nothing. Everything remains to 1 there. When I'm moving it here, is creating a 0 there. When I'm lifting from this pad and leaving only that, you see I'm sequentially doing it like that. It's still remaining 0. When I'm doing it this, still 0. And when I'm lifting from here, is becoming disabled. And when I'm moving it here, is actioning this other output here. You can see a green X on the positive input of the op-amp, you see, and this is actually this green X or the positive input is actually flipping this output when this is activated, and when I am sequentially moving forward right now, it's still remaining like that, off or 0 or enabled. This is enabled, now still enabled when I'm actioning this. When I'm switching from here is disabled right now, and now when I'm clicking this one other is enabled. So it's functioning absolutely perfectly, as you can see, and you see, is absolutely excellent. So the sequential is correct. The op-amps are doing the right thing. The problem is my 50 hertz is trembling, is creating an oscillation here, very, very fast, and on these inputs. And the op-amp is very sensitive, and it is reading those 50 hertz and amplifying them as well, creating a quite strong signal for the 7474 clock. Is my strongest opinion, is what I believe it is doing here. Most probably this is a problem, and why this didn't function in reality, but it did function absolutely perfectly here in the simulator. When I'm clicking, you see, manually like this, zack, 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 and so on. Yeah, that's it for this part. I hope you understood the issue, the problems, and I have a red X here and here because this extreme two are actually 0. It's not doing anything actually, but it's good here for exemplification, for showing the mechanism how it's working. So that's why I leave them. But in reality, I don't really need them. So I put a red X. I can cut them from the circuit and start directly with this and ending with the last one, which is that that is creating the 0. All right, that's it for this part.
This is doing exactly when I'm filming, but I made some tests and I did like this, you see, and it's working quite good. I like it. I kind of like it. So yeah, the trick here, instead of the thing is that is retaining the last touch, the last segment, the last element, and this is quite nice, to have this last element that you touched, instead of reacting only. And it's way more simple circuit when it's reacting only, but you don't know where it was last time. So if you have multiple buttons like that, this is a good indicator, very, very good indicator, scroll indicator. Yeah, it's latched. That's the idea, it's latched on its position. Fortunately, it's not working very well, but it's working. And when I revert to my original circuit, actually from these buttons here until that intersection between the diode and the clock pin, the wire that is going to the clock, here I have the transistor that is pretty much grounding. So the button wire is going to the base of the transistor through 10 kilo to the base of the transistor, and this wire is going to that intersection between the diode and the clock pin. This white wire is going to the clock, as you can see on the third here is going, and this wire is going there. And when this base of the transistor receives my finger input here, probably a static potential or static voltage from my finger, is opening this transistor safely through that 10 kilo, and is pretty much, and this is connected to the ground directly, and is putting a negative on this wire or on this connection here, and it's doing exactly the same thing as I was doing it with a single wire when I was connecting it like that with a wire, if you remember from my first video, or a simple button that I'm having there. So instead of this button, I have a transistor now, and these metallic elements that you're seeing there. Another role of this transistor, beside being a switch like that, is that is most probably why it's functioning here, and these errors might be related, this double trouble that I'm having there sometimes might be related to my 50 hertz that I encountered with the op-amps. And what I strongly believe now is that these transistors are dampening those 50 hertz. They are, it's my impression that is somehow is muffling, is diminishing that frequency under a certain level that is not readable by the clock of the flip-flop. But sometimes it is reading, this flip-flop is reading that 50 hertz sometimes, and is creating that double trouble, double lighting up LEDs. It's my impression. This is my impression. Another point, and I did test it with my debounced, here, it's having the name here, debounce button. And this is a debounce button with a Schmitt trigger not gate that you can see there. It's a very little, this black thing there, that's not a transistor. It's having 5 pins actually, and you can barely see them. And this the bounce button. I did test it with it. Sometimes it worked in some tests. Yeah, theoretically it worked. When I tested it with this op-amp, when I was having it with the LM358 here, it did action. It did toggle the flip-flop on the side I was clicking, but it was interfering with the rest of the circuit for some reason, and I didn't use it. But it was a very good idea to use that the bounce button instead of these buttons that I'm having here, and transmit that signal to whatever I had there. So my idea is to use the bounce circuit for every contact that I'm having there. Probably it will solve that double trouble that I'm having there. Yeah, you see, multiple trouble. Yeah, this is double trouble. Yeah, probably it's just I'm not completely sure why it's lighting up like that. It shouldn't. I was thinking I'm having problems between the chips when it's transitioning, but this is actually switching between the chips better than the flip-flops inside one chip. So rarely I'm having between the chips. Or maybe the distance. No, the distance is the same for everything. Another aspect, this arrangement that I'm having here is actually 1 0 1 0 1 0 and so on. Because this arrangement I had it from when I was using the op-amp. So even this was a failure. It didn't work at all with my circuit here in reality, but it did work exceptionally good in the simulator. I remained with this arrangement of the contacts, as you can see. So this is 0 1 0 0 1 0. Actually, I used only 1 0 here. So 0 1 0 1 0 1 and so on. And this is what I had. This is what I remained with this configuration. So basically, I'm giving a little bit of larger spacing here between this and this, because if it's too close together, and probably even larger space I should bring. Probably that's why I'm creating this. I'm somehow I'm touching two of them in the same time. But if I'm you see, I'm not completely sure. Yeah, well, it's a little bit buggy. I hope I can resolve this bug. I hope. But so far, I'm quite. It's not working without transistors at all. At all. If I'm not including this transistor, it's not switching. I have no chance to switch any clocks from these flip-flops at all. Unfortunately, directly linked from this metal pads that I'm having here directly there now. No way. So it must have these transistors by any means. Until I will resolve these problems, hopefully. So this was a little bit more troublesome than I imagined. This metallic contacts or pads, I call them pads because they will be pads. Right now are a piece of wires. In the final circuit, it will be a large pad. And most probably nicer than what I'm having here. Nicer looking and feeling, hopefully. So I had a lot of trouble and with these pads, with these links here, contacts. So originally I didn't think of them at all. It's just a piece of wire, it will do the job, probably capacitively, but most correctly right now is not capacitively, but most probably is the charge that I'm accumulated electrostatically on my finger. It's not really capacitive, it's more charging, and also frequency, 50 hertz most probably. So it's a combination of the two on this circuit. I'm not completely sure how it will work somewhere else in another ambient or in another medium. And yeah, we'll see. That's it for this part. I still have to resolve. So my biggest problem is to resolve this double trouble. That's all that remains to resolve. This double trouble issue. And my thought is to use the debounced circuitry for each one positive element, because as you can see there are some zero in the middles. And well, we will see. Wish me luck. And if you have any suggestions, write to me in the chat there. And give some suggestions. If not, it will remain as it is. It's good enough. And I'm very curious how it will behave on the cardboard in the final circuit. I'm very curious. But so far so good. I wanted to extend it with this third flip-flop here to be sure it is doing the right thing. And it is. And I'm very happy it is. Most probably something that is moving that is creating this double trouble. Triple trouble. So yeah. Motherfucker. Yeah, sometimes it's working, sometimes it's not working. I'm happy I got to this point until here. It's good enough for it's actually technology for my taste that I'm having here. Probably the easiest circuit is the reactive one when it doesn't latch anything, well, probably that's the easiest and the simplest and without any troubles like I'm having here. Who knows? All right. Thank you very much for watching and see you later. Bye bye. From your favorite artist, Mr. Q12. Bye bye.